Hello everybody. So in this session, we're going to continue with lesson 12.7, describe triangles. And the essential question that we're going to be able to answer at the end of the lesson is, how can you use sides and angles to help you describe triangles? And so in this activity, the unlock the problem, it says, how can you use straws of different lengths to make triangles? So if you have some straws and a pair of scissors, you might want to grab some of these materials. I have a couple that I've cut up and to demonstrate. So step one says cut straws into different lengths. So I have something like this smaller piece one, that smaller piece one, so on. Okay, so we have a bunch of straws with different lengths. Okay, some of them are of equal length. So it says then find straws that can be put together to make a triangle. Okay, so we know we have to have three sides, right? So let's try these three. Can we put these three cut straws together to make a triangle? Okay, well, let's see. They have to be end to end, so they have to be able to close. Okay, so I can put those three together. How about these three that were actually of equal length? Can I make a triangle out of those three? Two of the straws side by side. Okay, yeah, I can make a triangle out of those three that were of the same length. How about these three? So I'm looking at these three pieces right here. Will I be able to make a closed triangle? Oh, no. So what's the difference between these three, and these three? Well, let's look at one triangle at a time. Because it says compare the lengths of the sides, describe when you can make a triangle. So when we put two of the sides together, two of the cut straws together, and it was longer than the third piece, did it make a triangle? It did, right? Okay. And then we had this one we were looking at. We had put the two cut pieces together with the third piece. This time when I put the two cut pieces together, they weren't longer than this third piece. Did they make a triangle? I could close it, but look how far it's off of the. It's way over here. It has to be endpoint to endpoint. So there's no way of closing that triangle. So I think our general rule is that when two of the straws put together are longer than the third piece. or the third straw, you can make a triangle. When can't we make a triangle? We couldn't make a triangle when the two sides put together, when the two straws put together, were shorter than the third straw. So how could we have changed the straw pieces in step 3 to make a triangle? Well, we're putting these two straws together and they are not longer than the third piece. What if we traded these two smaller pieces for two pieces that were longer? Would that work? Let's see. Now that closes. So let's trade two of the shorter pieces, or two of the shorter straws, for longer straws. Okay. So what are ways to describe triangles? There are two ways triangles can be described. So one way is triangles can be described by the number of sides that are of equal length. Draw a line to match the description of the triangle or triangles. Well, so let's see. This one is 1 inch, 1 inch, 1 inch. Okay, so this one, all sides are equal. So that would go to this one over here. 3 sides are of equal length. Okay, how about B? One and 4/16. 5, 6, 7, 8, 9. 13/16. 16. Okay, so what I'm doing is just measuring them to see are they of equal length. Okay, so when I look at these two, I see that these two sides are equal and these two sides are equal. The third side is not equal. So two of the sides are equal. And so these three, they're probably not the same. Any of the sides are probably the same. Okay, so I counted 7 out of the 16 marks for this line, the line segment. Counted 12 out of the 16 lines for this one, and I counted 14 out of the 16 lines for this one. So all three sides are different. So no sides are equal. Okay, so what are the three ways we can describe a triangle by its sides? We can say all three sides are equal. We can say two of the sides are equal, or we can say no sides are equal. All right. We can also describe them by their angles. All right, so let's look at just this angle here. If I put the tool that we've been using to measure, I see the line segment lined up with the edge of my paper. The corner of my paper is at the vertex, and this is off of the paper. Okay, so that means it's greater than a right angle. So one of the angles is greater than a right angle. That would be one way to describe them. And then we see that we have three angles, and what measure are those? Well, let's just take one corner. Okay, I see the orange line segment lined up with the edge of my paper. The corner of the paper is at the vertex, and I cannot see the other line segment. So these are less than right angles. So three of the angles are less than a right angle. And then remember that what's this symbol mean? It means that it is a right angle. So these two triangles have right angles. So one angle is a right angle. So the three ways we can describe it by angles is one of the angles in the triangle is a right angle. We can also describe it if one of the angles is greater than a right angle. And then we have one that has all three of the angles less than a right angle. All right, so let's practice some of these. So there's two ways to describe them, either by sides or by angles. So number one, write the number of sides of equal length the triangle appears to have. Okay. When I just look at this, I think these two sides are going to be equal. But let's check. So I put my line segment at 0, and as I count, I see that I reach 1, and then it's 1, 2, 3, 4 marks past. And there's 16 marks in the whole thing. So this line is 1 and 4/16 inch long. How about this one? Okay, again, I put it at 0. I see the 1 mark, and then 1, 2, 3, 4. Again, so 1 and 4/16. Now my guess was that this is shorter than the other two. And it is, right? So this one is less than 1. It's 14/16. Okay, so it's not even 1. So write the number of sides of equal length the triangle appears to have. Two sides of equal length. Use triangles 2 through 4. Write F, G, or H. Triangle has one right angle. Okay, well, that's this one right here, right? Based on the symbol that they're telling us that that is a right angle. So triangle F has one right angle. which one has a triangle that has an angle greater than a right angle? Well, I'm going to say H has an angle greater than a right angle. And I can check that. I put that there. The orange line segment of the top of the triangle is lined up. And this part of the line segment is off of the paper. So this angle is greater than a right angle. H. And then 3 angles less than a right angle, that has to be this one right here. So I put the measurement there, compare it to the corner of a sheet of paper. I see the orange line segment go across the edge, but I can't see the other side. So this is less than a right angle. Compare the top one. Okay, again, I see this line segment of the angle here, but I can't see the other one. That's 2 sides that are less than the right angle. And just confirm the last one. Okay, I see the line segment on the bottom, but I can't see the other line segment because it's under the paper. So G has 3 angles less than a right angle. All right, for triangles 5 through 7, write K, L, or M and complete the sentences. Triangle blank has 1 right angle and appears to have blank sides of equal length. Well, M has 1 right angle. How many sides does it appear to have of equal length? Well, let's check. So it's greater than 1. It goes 1, 2, 3, 4, 5, 6, about 1 and 6/16 for that line. This line, we're going to call that 1. And the top, we'll also call that 1. So it has 2 sides of equal length. All right, which one has 3 angles less than a right angle and appears to have blank sides of equal length? Well, K looks like G, right? K looks like the angles of G. G had 3 angles less than a right angle. So K has 3 angles less than a right angle. And how many sides of equal length? It kind of looks like they're all the same. I'm going to say that that's 14 out of the 16 lines or sections. Same thing on this side. How about this side? Yes, also 2/16 short. So, and it has 3 sides of equal length. How about 7? Triangle blank has 1 angle greater than a right angle. Well, L kind of looks like H. It's got this angle right here that looks like this angle. So if I compare it to a corner of a piece of paper, you notice that this part of the angle is off of the paper. So that is an angle greater than a right angle. So L. And then when I look at them, it doesn't look like any of the sides are equal, but let's check. So almost 1.5. I'm going to call it 1 and 9/16. Okay, this bottom one, pretty much right at 1. How about this one? Oh, that one's less than 1 by a great deal. Let's see. 8, 9, 10, 11, 12. 12/16. So, yes, no sides of equal length. So let's review. Triangle M has a right angle, and it had two sides of equal length. K had three angles less than a right angle, and all three sides were equal. Triangle L had an angle greater than a right angle, and no sides that were equal. Okay, 534. Number 8. Martin said a triangle can have two sides that are parallel. Does his statement make sense? No. Let's just look at this. If you have two sides of a triangle that are parallel, how are you going to make that a closed shape with only one more side? No. Okay. Triangles only have three sides. So if I close it here, it's still open. That's not a triangle. Okay. So the least amount I could have with a parallel side is four sides. All right. So number 9. Compare triangles R and S. How are they alike? How are they different? Well, how are they alike? Well, they look like they all have, or they both have, three angles less than a right angle. Let's check that out. Okay, so that angle here, this first angle, is less than a right angle. How about this one? Okay, so this angle is also less than a right angle. And the last one. Okay, I see the green line here, but I won't be able to see the other side, so that's less than. So all three sides of R are less than a right angle. S. Okay, well that angle is less than a right angle. This side I can't see, that's less than a right angle. And the last one. Okay, I can see this side lined up with my paper, edge of my paper, and I can't see this side, so it also has. So they both have three angles less than a right angle. Let's measure the sides. So this triangle, I'm going to say it's 14 out of the 16. Let's say this is 14 out of 16. And so is this one. So all three sides of R are equal. How about S? It kind of looks like these two sides are equal, but not this one. Let's see. So this is slightly longer than 1. It's 1 and 2/16. So is this one. So 1 and then 2 more marks. 1 and 2/16. And then the last one is not to 1 yet. Okay, here's 1, but the triangle ends here. So I would say this is 14/16. Triangle R has 3 equal sides. S has 2 sides of equal length. So how are the shapes different? They both have, how are they the same? They have 3 angles less than a right angle. Triangle R has 3 equal sides, and S has 2 sides of equal length. Okay, number 10, use a ruler to draw a straight line from one corner of this rectangle to the opposite corner. What shapes did you make? So from one corner to the opposite corner, what shapes did you make? We made 2 triangles. What do you notice about the shapes? Well, aren't they exactly the same? Okay, for instance, they both have one right angle. The right angle, and that's a right angle. So they're kind of mirror images of each other. And 11, write the name of each triangle where it belongs in the table. Some triangles might belong in both parts of the table. Some triangles might not belong in either part. All right, so which triangles have one right angle? Okay, well, let's look for the symbols. So all of those that have the blue square are right angles. So triangle L, triangle N, triangle P, and triangle R has one right angle. Has at least 2 sides of equal length. Okay, I'm going to call this about half. Actually 9/16. Let's try this one again. Oh yeah, 9/16 has at least 2 sides of equal length. So J. How about P? Are these 2 sides the same? One, two, three, four, five, six, 7, 8, 9 out of the 16 marks. 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 16 marks. So P. How about R? Are those 2 sides equal? 8, 9. 8, 9. So R has at least 2 sides of equal length. How about O? Are those 2 of equal length? So 8, 9, 10, 11, 12, 13. I know it's not equal to that one. So let's try its opposite side. 8, 9, 10, 11, 12. 8, 9, 10, 11, 12. try this one again then. 1, 2, 3, 4, 5, 6, 7, 8. O, Q, all sides are equal in Q. Maybe L. 7, 9. Okay. So, no. So that's what I've come up with so far. I don't believe K and M would be of the same measurement. They just don't look like they have equal sides. Okay. And Q had what appears to be equilateral. So the one right angles, L and P and R, and two sides of equal length, J, P, R, O, and Q. So how can we describe triangles? We can describe them by the size of their angles. If they have one right angle, whether they have all three angles less than a right angle, or whether they have one angle greater than a right angle. We can also identify them by the measurements of their sides. They can have no sides equal, they can have two sides equal, or they can have three sides equal. So that's it for describing triangles. In the next lesson, we'll be talking about how to classify plane shapes. So until then, may the numbers always be in your favor.